Here we go. All right, so with graphs, we also have the domain, the intercepts, which are the x and y intercepts. We also have domain and range. Excuse me. I mean, the domain we know already, it's always the same for quadratic functions. The intercepts here, the y-intercept, that's easy. That's just f of 0. The x-intercepts, we have this equation to solve. And that's what you do normally, for any function, actually. So in this case, we do that here, for this. And what do we use for that? Well, we can factor or use that formula. I mean, factoring, as we know, is important, but most of the time here, we could just use the quadratic formula. Sometimes that's better because the roots may be, how do I say this? They may not be nice. Well, you'll see what I mean when we do examples. They may not be nice numbers. So for the range, you can get the range without even graphing this. Assuming you know the vertex and A. It turns out if A is positive, the range is always going to go from some number, namely the y-coordinate of the vertex, to infinity. Let me draw this. I didn't draw it for the other class, but let me draw it for you guys. I didn't draw it for the other class because I didn't think to do it. But basically, if A is positive, right, you know the graph's going to look something like this, as we already saw. So the vertex, which is down here, okay, the range is going to go from the vertex up to infinity. If A is negative, the only difference is that instead, okay, it's going to go from minus infinity up to the vertex. So you're either going to get some number to infinity or minus infinity to some number. So, I mean, if you graph it, then you should still be able to get the range that way, but you can get it without graphing it in this case. All right, let me, here we go. Okay, so that's good. I think it's probably time to do examples. Yeah, okay, so let's dive right in and do an example or two. I know it's probably confusing what I have here, but again, when we do some examples, it should make sense. So here, let's say this one. So really what you want to be able to do is determine what A, B, and C are. So that's what you want to be able to do, at A, B, and C. So A we know is the leading coefficient, the coefficient of x squared, which is 2 in this case. B is the coefficient of x, which is 8 in this case. C is just the constant term, which in this case is minus 3. Now let me get to the vertex. So here's the formula for the vertex. So we have to calculate minus B over 2 times A. Here we go. And that's what I'm calculating here. At x equals, well, that's going to be the axis of symmetry, but we have to get minus B over 2 times A. So we just substitute. We get minus 8 over 2 times 2, which is minus 8 over 4, so that's minus 2. Now the vertex, though, we have to get the y-coordinate. That's the function value. So I'm doing f of minus 2. And you know, you plug it in and do the calculation. You get minus 11. Okay, so what do we have then? We have the vertex, right? As you can see, right? Minus 2, minus 11. We have the axis of symmetry. And again, you can get the y-intercept easily. You just replace x by 0. I mean, if you do that here, you'll just get the constant term. And notice, since A is positive, we know right away the graph is going to open up. In fact, since A is positive, the graph's going to do something like this, as you can see. The vertex is down here. Let me see if I could draw that. Minus 2, minus 11. Okay, as you can see. And actually, we can get the range easily because it's opening upward. So the range is going to go from minus 11, comma, infinity. So that's what the range here is actually going to look like. I'll show you the graph shortly, and I'll show you how to get the range from that. Although really, you could just use what we've done in 2.4. But you can see that we have the range already. All right. Well, the only thing here we're missing is the x-intercepts. So we have to calculate that. On an exam, I will tell you what you need to get. You don't have to memorize it. I'll tell you, find the vertex, find the axis of symmetry, stuff like that. I might not ask you to graph it because if it's take home and you have Desmos and GeoGebra and stuff, so I mean, I kind of would defeat the purpose of asking for me to ask you to graph it. But I might ask you to calculate the vertex and show your calculations. So for the x-intercepts, again, I mean, you could try factoring this, but I personally would just use the quadratic formula, which I have here. So here, as you can see, we have minus b, right? Plus or minus the square root of b squared minus 4ac, or 2 times a, right? We have all this. And so from here, we have this. Again, a, b, c. I'm substituting. So we get minus 8 plus or minus square root of 8 squared minus 4 times a times c, as you can see, over 2 times a, right? So from here, we get this. Right, I'm just evaluating everything. So we have 8 squared, which is 64. We have minus 4 times 2 times minus 3. Minus becomes plus 4. Excuse me. And so we have all this. So that's what we get here. And it turns out the square root of 88 is not a nice number. Basically, by a calculator, although actually I think I used Excel, that's how I got these numbers here. I'm not sure if I was consistent with rounding, but I would also tell you how many decimal places to round to. So once we get these numbers and then we approximate, as you can see, now we can actually graph it. Although I did graph it by GeoGebra, as you can see. Now we have the vertex, which is down here, -2, -11. We have our x-intercepts, and we have our y-intercept. Let me just draw the axis of symmetry. That's a vertical line through the vertex. That's why I have here x equals -2. So bear with me. I know it was stupid. It was silly of me, that is, excuse me, to not skip through GeoGebra. I don't know what happened, but anyway, we have this, as you can see. And again, that's the axis of symmetry. So the graph is, at least I hope it is, symmetric about this line. So in other words, you could take the graph and, one second, fold about that graph, about that dashed line. Both halves would match up. I had a question? Gone. Sorry.
How did you solve for the y-intercept?
Oh, for the y, I just replace x by 0. And doing that, that will kill off 2x squared and 8x. It basically will become 0, and you're left with -3. It's also just the constant term, the term with, oh, darn it, sorry, the terms with no x's. Sorry. It's just also the term with no x's. So does that help, or?
Yes.
Okay, you sure? because I did move the slides a bit when I was trying to explain it, so I'm sorry about that. But again, for the y-intercept, you just calculate f of 0. And if you did that, you would have 2 times 0 squared plus 8 times 0 minus 3, which is minus 3. So does that make sense to everyone? I'll take that as a, okay. I heard a yes, so okay. So that's what happens here. So that's a good question. So I know I didn't show the calculation, but again, that's really what you would just do. For the range, we were right. It was from minus 11 to infinity. Okay. Now you could actually get that from the graph as well, mostly because if you remember from section 2.4, you could think about taking the graph and pushing it horizontally onto the y-axis. And what you would end up with would be the range. So hopefully, I mean, I hope at least you see from here, by drawing these horizontal lines, right? Hopefully you can see that the range would be everything from minus 11 all the way up and up and up, and it would never stop because the graph never stops climbing. So basically you'd be doing these horizontal lines forever. I mean, I hope that helps because it does take a little visualization, but that's the idea, of how you get the range that is. So, okay.